Okay, so it might be a bit hard for you to hear me. There's traffic going by. It's that time of the day, and this is my little assistant Lexi, my niece. Okay, so I just something has happened along my math career, and I've never really learned my times tables, so I've got her. But anyway, okay, so we're gonna look at this one first, and it's p to the 5th times p. You might not look at that and say times p, but when something's next to each other, it's multiplied, okay? So p to the 5th, p over p to the negative 1st, okay? So what you should be thinking automatically is that this p has an imaginary, it's raised to an imaginary first power, okay? Or raised to 1, okay? So there always is an understood p there. I don't like using imaginary because that's a whole nother area of math. Imaginary numbers, okay? But, so now this is looking like p to the 5th, p1 over p to the negative 1st. The first thing we need to do is use our product rule and add p to the 5th plus 1, okay? So we would get p to the 5th, I write it small, plus 1 would equal p to the 6th, okay? So now we're working with p to the 6th in our numerator. That's how we simplified the top, okay? So that's simplified. We got p to the 6th. Now it's over p to the negative 1st. Now what you should be thinking to yourself is what I always tell you, okay? That when we're doing this quotient rule, the rule says to subtract the exponent in the numerator from the exponent in the denominator. So by that, you can't just look at this and say, oh, 6 minus 1. Okay, you would get 5, and that's not the right answer. Okay, so this is why I stress writing it out. So you think of 6 minus negative 1, okay? Because we have a negative 1, so we have to still subtract and then use what we got. So negative 1. So two negatives make it a positive. So we really have 6 plus 1 after we understand that, which is equal to p to the 7th, which is our answer, p to the 7th, okay? So make sure you've got that down. The answer is p to the 7th. Okay, and I'm gonna erase it and make it cleaner in a second. Okay. P to the 7th. Alright, so now for number 2 we have 9k to the 4th over 3k, okay? So the first thing we need to look at is let's start simplifying, right? So that's basically what we're looking for first, is just to simplify, right? We simplified the numerator here by turning this into p6, okay? And then we worked further along. So how do we simplify here, okay? Because there's no multiplying going on, nothing like that. We could use our quotient rule, but let's make these numbers smaller first since we see that 3 can go into 9. Everything's good?
Yeah, just a little battery.
Okay. Alright, so 3 can go into 9, right? How many times? The larger number's in the numerator, so we know it goes in 3 times, okay? So we've got 3 now that we're working with, and then it's got k to the 4, and then k. So remember, this is 1, okay? It's not negative or anything, so now we're just working with 4 minus 1, right? So when you write that out, 4 minus 1 equals 3, okay? So that means we've got 3k to the 3rd, okay? Nothing was negative. There's no using the reciprocal. There's no negative exponent rule or anything right now to think about. Okay, just 3k to the 3rd. I'm not going to make it too complex. Okay, so that's good for that one. All right. I think I'm going to work them in a different color and then write the answer in red. That works. Okay, we'll use blue. All right. So now we're going to be using our power rule. Okay, power rule. It looks just like this, okay? So if we were to cover this up and we've got a to the 5th in parentheses and then to the 7th, that's our power rule. We're going to use our power rule, which basically means that we're just going to multiply these two, okay? The exponents, okay? So when we multiply 5 times 7, what do we get, 35?
Yes.
Okay, so we've got a to the 35th now. And we can write it over. Well, we need to write it over because right now we're just simplifying. My apologies, okay? So then we have a and then 6 to the 9th, or a to the 6th times, or raised to the 9th. I'm trying to be technically or politically correct here, but a to the 6th raised to the 9th is how you'd say that. Okay, so we get a to the, 54?
Mhm.
Okay, a to the 54th. Okay, so now you kind of see how we're in a pickle right now. We have a to the 35th over a to the 54th. You should think to yourself that we need to use the, think about it, quotient rule. Okay, we need to subtract now. Okay, so we need to subtract 35 minus 54, which is fine. We can do it like that. We'll still get the same answer, right? But I like to write it. I remember that if it's a smaller number being subtracted, actually let me be PC here right now. If it is a larger number being subtracted from a smaller number, even though you're looking at it and thinking of it differently, I just like to go ahead and write the bigger number over to work it out like that, and I'll remember that it's a negative. Okay, so we have to borrow. We get a 4 here, 14, 13, 12, 11, 10, 9. Okay, we get 9, and then we get 1. So we get a to the negative 19th, because we have to remember it's a negative though, even though I wrote it like this, right? Okay, so we have a to the negative 19th. How do we make that negative 19th positive? Because an exponent cannot stay a negative. Okay, use the negative exponent rule. You put it in the denominator and you put 1 over it. Yeah, okay? So our answer would be, and I'm going to erase this, make sure you have this work right here. A to the negative 19th, 35 minus 54. Okay? So we just get equals 1 over A to the 19th. Okay? That's the answer. Alright? So now let's go ahead and we've got x to the 9th, x to the 5th over x to the 10th. Okay? So we can use our product rule and add these. Let me make sure I'm stating these rules correctly on this one. The product rule, that's just the one adding, I believe. Yes. Okay. Sorry. That one, I don't know why. That should be the simplest rule, but sometimes I just have to think about these rules. I'm just so used to working on them. Okay. So, let's add these because they're right next to each other. We need to simplify them. We need to combine them, right? Okay, so that's what we're doing. We're using the product rule. So let's combine x to the 9th, x to the 5th, we get x to the 14th, okay? So x to the 14th over x to the 10th, okay? There was nothing to combine or simplify down here, so we just brought it right over here. Alright, so then we have x to the 14th divided by x to the 10th. What do we do? What rule do we use? Okay, the quotient rule. Okay, so when we do that, we're going to do 14 minus 10, I like to write it, 14 minus 10, we get 4, okay? I like to have clear writing. That's the type of person I am. Obviously, I can do that mental math, but I like to write it, okay? Especially when there's a negative in there. It's a good habit, okay? So then our answer is we get x to the 4th. Is that right? Can you double check that for me? Just because I erased that, no, I was just talking. Okay. So x to the 4th, okay? So that's our answer right there. Alright, so now we get to take a look at when we have something raised to the 0 power. The rule is when anything's raised to the power of 0, it equals 1. But let's think about when there's a negative in front of one of those numbers. It would just be negative 1, okay? So negative 7 raised to the 0 power is really negative 1, okay? So negative 1 plus, oh, I should be writing my work in a different color. Not that there's much work here, but, so we have negative 1 plus, again, what did I say? Any number raised to 0 is 1, so 8 to the 0 power is just positive 1. Okay, so when you have negative 1 plus positive 1, it's just going to equal 0. Okay, so our answer is 0. Okay, I'm going to erase that, and write it right here, so we get 0. Okay? It's pretty cold out here. Alright, so now we're getting to number 6. We're going to use our power rule first to simplify these right here. So let's go ahead and do 4 times 8 is what? I don't even know.
4 times 8, 32.
Yeah, 32. Okay, so m, let's see. When we use our power rule right here, we get m 32. And then we still have m, right? So that's our new numerator. m 32, or m to the 32nd power m. okay? And then it's going to go over M16, okay? So let's use our product rule now because we have M32M. That's an imaginary 1 right there next to that M, correct? So we have to add those, okay? We have to use that product rule, okay? So 32 plus 1 would be, that gives us M33, okay? So we have M33. I'm very inconsistent. I was saying I shouldn't be writing my work in red, only my answers, but here I am, okay? So now we have simplified at the top 2, and we have M33 over M to the 16th, or M to the 33rd over M to the 16th. Okay, now we need to use our quotient rule and subtract, okay? So we do 33 minus 16, okay? We borrow, we got 2, 13, what is that? 7, 6, 7, 8, 9, 10, 11, 12, 13. I'm so lost.
What are you trying to do? I'm sorry.
6,
Oh,
7, 8,
33
9, 10, 11, 12,
17.
13, 7. No, it's 7. Okay, so 7. And then we got 2 minus 1 is just 1. So we have m to the 17th power. Is that correct? Is that the answer? M to the 17th power? I don't know why that one was such a weird one for me. Okay. I don't know how to multiply and I don't know how to subtract. Okay. So m to the 17th power is our final answer. Equals m to the 17th power. Alright. So moving on. Now we have r over r to the negative 7th, r to the negative 5th. Okay. The top, the numerator is fine right now. Okay. So that's simplified. That's how you need to think of it. Alright, so we still have r in the numerator, right? Alright, now let's think about simplifying this bottom one. Alright, so what are we going to do? We're going to use our product rule, right? These are just multiplied, so let's just add those, okay? Now again, if you look here, that's the power rule. When there's something needed to be multiplied in terms of the exponents. But this, it's just these bases are multiplied. So let's add those exponents, okay? So we have negative 7 plus negative 5. We get equal to negative 12. Yes, okay? So that gives us r negative 12. Okay? So in the numerator, if you can't really see that well, it says r. In the denominator, it says r to the negative 12. Okay, now remember, don't forget this. This is an imaginary 1 that we have to do something with, right? There's an imaginary 1 there. What do we have to do? We have to use our quotient rule now to subtract, okay? So we have 1, and let me write this big, 1 minus negative 12. Okay, not just 1 minus 12. You'll get negative 11. Okay, 1 minus negative 12. So when you see the two double negatives, you add them, and we get r to the 13th power. 1 plus 12 is 13, okay? So our answer is r to the 13th power. Turns out it's positive. So, let me write that. R to the 13th power, that's good? Equals r to the 13th power, okay? Alright, so now number 8. We have 1 squared over negative 2 to the 0 power. Alright, so think about this one. 1 squared is just what? Well, 1 times 1 is just 1, okay? So we have 1 in the numerator. Okay, now what do we have at the bottom? That's kind of like what we thought about here. Negative 1, right? Anything raised to 0 power is 1. Well, there's a negative in front of it though, so it's going to be negative 1. Okay, so negative 1 in the denominator. So we have 1 over negative 1, which is just what? Negative 1, okay? Because anything over itself is already 1, so even if this was 2 over negative 2, we'd still get the same answer, negative 1, alright? So our answer for number 8 is negative 1. Alright? Alright, last one. Okay? I'm probably going to erase some of this, just so I could, I mean, there's really not much to this one, so maybe I could squeeze it, but I'm going to at least erase this one and maybe this one. So make sure you have these down, just so I could have a little extra room here at the bottom. Okay? So that was negative 1, R13, yada, yada, yada. Okay, so first, let's think about simplifying. Let's get the numbers smaller, right? Okay, so we have 60, we have 10. We know that 10 goes into 60. Okay, so that would give us a 6. Okay, I'm gonna write this over here. So that will give us a 6. All right, we'll go with the 6. Those are simple. Boom, boom, blah, blah. Okay, so now, well, there's an X and an X, a Y and a Y, and a Z and a Z. And we're in good position, okay? The top numbers are all bigger. Either way, even if they were smaller, what we would be doing now is the quotient rule. Okay, so we do, we have X, we know, okay? And that would be X, 5 minus 3. 5 minus 3 is 2, so we have X squared. And then Y, what do we have for Y? We have 9 minus 5 equals 4, so we have Y to the 4th. And then we have Z, 7 minus 3. 7 minus 3 equals 4 again. So Z to the 4th. Okay, that's good? All right, so that is the answer. Didn't give anything too crazy. We're not working with too many negatives, especially in terms of the exponents. I don't think any of them are, except this one. This one did come out negative, and we have it over 1. But that's good to go. What else came
First
out
one,
negative?
maybe.
No. Well, yeah, but not the answer.
probably.
But yeah.
Yeah.
Yeah, we did look at a negative exponent. Okay, so even though I didn't write it in red, that's the answer right here. 6x squared, y to the 4th, z to the 4th. Okay? Alrighty. Lex, you can stop the video.
Okay.